welcome to Ladyada.
Hey everybody, and welcome to my desk. It's me, Ladyada, with the confidential data sheets. Doing some hacking at my desk. A little rainy, so I did get a little bit of hardware done this weekend. Mr. Ladyada, do you have any news or updates for people?
Yeah, you're going to show the cool project we did for our kiddo later. And
Yeah.
normal shows this week, we had a lot of designs we published across all the social media channels. We have a high thread count, as they say in the sheet biz. Anyways,
Okay, well, actually, let's show that toy thing first, because it's right on my desk. Let's go to my desk. Oh, wait, you want to see the video first? You want to show that? Okay, so as you saw, Mr. Laydata, he's actually going through and creating all the things he's always ever wanted. So he always wanted a bear that could quote from Shawshank Redemption. He always wanted a purple Prince music player. I think Emil Dev should probably dig this too. But it's a spray painted baby Einstein toy, and he printed out this symbol that Prince used in his career. And then you can see here it's using a non-toxic paint that we found. And inside is our board that runs CircuitPython, and the files are on the SD card. Now, because it's a baby toy, of course, it's all screwed closed, so it's not easy for me to open it up. But let's go to the computer and I'll show. We actually have the PCB in the shop for signups if people want. So I'm going to do another revision of this board. So this board, I think I demoed it a couple weeks ago or a week ago. It does work. The power supply has been fixed up. Everything's kind of in the same location, but basically now I boost from the 2 AA's to 3.8 volts, and then it goes through a regulator. Not super ideal, but definitely works fine, and isn't expensive, and uses parts that I already stock, right? Which is kind of the most important thing. So a couple of things I want to fix up is the switch is used to detect. The switch is used to change the volume, and right now that volume input goes straight into the amplifier, like just literally connected to the gain pin. But it turns out that the this chip, I think, only samples the gain pin, like either the beginning of boot or something. It's not dynamic. So I'm going to reroute this pin to go into the microcontroller pin, and then when the microcontroller detects that the switch is at the low speaker or high speaker, it'll change the mixer gain. So you'll do software gain rather than trying to do like hardware gain. And what's the other thing I wanted to fix? I might try to move this. I know it's would be a huge route, but unfortunately there's a little bit of plastic that bumps up right up against the metal tin here. It turns out that the outline of the PCB is correct, but the height isn't matching. The original board was very, very flat. So the tin is bumping into the plastic, and I got to decide, can I move it? And if not, I'll just tell people, hey, you have to just clip or file away a little bit of plastic so that the case can close. So my little hacker board is working great. SD card stuff works, internal storage works, Stomach QT, programming, amplifier, boosting. I also have to do a little bit of low power testing and make sure that that's good. But otherwise, we're getting very close. I think there's one more revision, and of course, we'll do some fun silkscreen stuff. Okay, so that's the My Little Hacker board. So proof of existence. Next up, okay, so go to the overhead again. So I've got this USB hub breakout board that I designed using the SL2.1A, and it's a very simple hub. You have USB-C to A here, and then these 4 ports. To do testing, I'm using these cables that we stock, that they're just USB to the red, black, white, green, data plus, data minus. There's no USB serial converter, there's no adapter, there's nothing. It's just straight up wire. So this is very handy if you're just hey, I want to verify that this port works. So the hub works, and then the next step is, how do I write the tester code? So it does turn out that TinyUSB, which is what we use as a core for the RP2040 host support that we've added a couple months ago, it does support hubs, although right now the demo only shows one device. Like if I plug in the hub and I plug in 4 things, it's like it only sees the first item you plugged in. So I chatted with TAC, asked him, hey, could you like verify? Because it should work. Like I've seen people using TinyUSB through a hub, and that'll let me test the functionality really easily because I'll just have like 4 devices plugged in via pogo pins, and if they enumerate, then I know it's good to go. So that's happening, but not quite done yet. And then I got some flex PCBs. So JLC PCB has the ability to create flex boards for like fairly inexpensive pricing. So I got this design. It's an open published design from Makers Making Change, and this is kind of an interesting idea. It's called a battery interrupter. So it's a flex PCB, and then there's a contact on this side and a contact on the other side, and this would go between 2 batteries, right? So if you have, usually the back of a toy has like multiple batteries in a row, you would slip this in between. And then these 2 contacts aren't connected through together. Instead, one goes on the top and one goes on the bottom, and then they connect to this jack switch. So if you have accessibility technology buttons, AT buttons, they usually have a 3.5 millimeter like audio mono jack, and that's what they use. So this is a jack, and then the AT switch would plug in. And then instead of trying to modify the toy, which is usually kind of like, you have to open it and like there's screws and you're soldering and there's epoxy. Maybe you just keep the toy on at all times, and then you use, and you maybe tape the button down or something. So it's like always like activated. And then you'd use this with the AT switch. So there's like a no solder solution or no toy opening solution. So I thought this was really cool. I might contact them and say like, hey, can we stock these? Because this can be useful for other things where you want to automate them. You have a device and you want to IoTify it. Especially if it's running off of batteries, it can like be very annoying to try to automate it, like and control it with a relay. But maybe you could use something like this, and then you use, you could use a MOSFET switch or a small relay, but at least you're not opening up the device and soldering wires into it. So I thought this was kind of neat. This is from Makers Making Change, and it's called the Flex Battery Interrupter, and they have 2 versions, and I just picked up some of these, and they were only a couple bucks a piece. So I thought that was kind of cool. Next up, I have a design that actually designed like a couple months ago, and it was for my own internal usage. But I thought it'd be useful for other people as well, because I was trying to like do a lot of testing with SPI displays on Raspberry Pi. So this is, we're calling it a Pi Beret, like a Raspberry Beret, because we were listening to Prince. So it has, it's, a very slim board that plugs in via the 2x20 header. And it's got 2 buttons, 5 and 6 GPIO, and then GPIO 13 has a slide switch. And then this is an iSPI connector, so this has SPI, I2C, and a bunch of GPIO on it as well. And you can connect it to small screens directly. And then this is, of course, STEMMA QT going to the I2C port. And then there's pull-ups and all this stuff. And the reason I did pull-ups is because I wanted this to work. One thing I noticed is that Blinka, which is our CircuitPython library API compatibility library for Python, when you're running our libraries on an example sketches on boards that are not the Raspberry Pi, they don't have a built-in pull-up resistor capability because they're using the kernel GPIO. I can't remember the name of it, the GPIO kernel module. It doesn't have support for pull-ups. Even why, I don't know. Software people writing code for hardware, they didn't think to add support for pull-ups, and so you can turn the pin to an input or an output and set the level, but you can't have an input with a pull-up. So you want to have external pull-ups. So these buttons and switches and the chip selects and all that stuff that are in here have 10K pull-ups on them. So that's the packs over here. And then there's the backlight for the display connected to GPIO 18, because that's the one pin on the Raspberry Pi that can do PWM. So, yeah, this is just a prototype, but I cleaned up the silk screen and I ordered this. So I think it might be useful for people who want to just like, okay, plug and play, and I can connect iSpy for e-ink or TFTs, some buttons, switches, and sensors. So you can do like some IoT projects probably without any wiring, and you know, not using a shim board, like it actually plugs in. So that's coming soon. And then the last thing we're working on, so I just got these prototypes like Friday morning. This is like a this is a 2020 mid 2020 project. It's a ICN6211, which is a chip that can do DSI. This is a 15-pin DSI, which may look familiar. It's the same DSI port that's on Raspberry Pi computers, but it's now on like a lot of single board computers. So this is DSI MIPI 2-lane, and it goes into this chip, and then this chip will convert that into 40-pin parallel. And the reason you're like, oh, well, can't the Raspberry Pi do parallel on its own? Yes, it can. It can do 16-bit color parallel. This is 24-bit, but it can do 16-bit. But it uses like all the GPIO, and it's annoying. And wouldn't it be great if you had the GPIO available still, so you could have you know, IRQs and interrupts and SPI and stemma QT and buttons. But the display goes through the DSI port, and there are, you know, like I think DF Robot and Waveshare have made displays that use this chip, but everything is like closed source blobs, and they don't document how it works. I wanted to make a dev board that allows like anyone to connect. Like there's a lot of different screens, and like square and circle, and this is a kind of a standard 4.3 inch, but there's 5-inch, 7-inch TTL displays. And then, you know, maybe we can document how to write the I2C commands to this chip to get it set up. And then you have a device tree overlay that would let this appear as the console. So that way you have all the GPIO still left over. And if you go to computer, one thing that has changed, thankfully, is there's now Linux support for this chip. It was written in 2020, so it's ironically like around, you know, around the same time I was designing the board, probably. Originally, this kernel module got added, but then I couldn't get chips for a while, and then kind of like this sort of fell by the back burner. So what you have to do with this chip is you have to tell it what the display is and how to communicate with the TTL display, because maybe it's a bidirectional communication protocol, but TTL displays don't have any data coming back. Like you blast out the pixels and you're like, I hope that there's something on the other side, and I hope I got the configuration correct. So you do have to set it up. You have to set up you know, how wide it is, how tall it is in pixels, of course, and then stuff like, you know, the clock rate and the front porch and the back porch, and how many H-sync lines you need to, you know, whatever, blah, blah, blah. You know, there's all these settings that you have to tweak. And sometimes like the H-sync has to be low, and sometimes it has to be high. And like, you know, I've kind of seen everything. So, you know, looks like there's a, oh, cool. There's like a debug mode. So I found like this like confidential, but like not really. You just Google around, and I found this this like data sheet, but it's not like really a data sheet. It's like there seems like there's 15 different like half data sheets, but sorry, it looks like there's 4-lane plus clock. Although maybe this is, I don't know, unclear. Maybe it's only 1 lane. It merges the lanes, and then you can get 24-bit color output, H-sync, V-sync, data enable, and P-clock. And then it's I2C. So I did design this. This is the board. So let me quickly show some of the design decisions I made. Turns out I made like a lot of mistakes on this board, but that's okay. So this is the ICN6211 here. And you can see it has a lot of, I didn't put little usually you put like 22 or 33 ohm resistors just to kind of reduce the ringing. I didn't do that because I was kind of in a rush, so I just routed these through. There's a backlight controller over here, and then I'll show maybe sorry, where's my oh, can you go to the overhead? So one thing to notice about TFTs is each section is like separate. Like you might think of it as like, oh, it's a touch display, but it's actually like 4 different things. There's the TFT itself. There's the capacitive touch overlay, which is its own separate component that's glued on top, and it has its own chip and own power, data, and I2C. And then there's sometimes resistive touch that comes through over here. This is a capacitive, not resistive, so there's no resistive overlay. And then there's the backlight control, which again is handled separately. So this is the backlight converter, and I'm using a TPS61169, which is kind of a nice chip. We covered this in a previous great search. I was looking for parts to replace, I think, the fan 333 or fan 5331. I don't remember which one it is, but there's a constant current backlight driver chip that got discontinued. And so this is a nice replacement. What's nice is, one, you don't need to have this protection diode. It automatically, it won't overheat if you have the backlight disconnected, which the fan 533 did have a problem with. So that's not needed anymore. And then you can see, this is just showing junk. It's whatever, it's in the memory. But, just testing the backlight. If I short the 100 milliamp, this is the 50 milliamp. You can see it gets a little bit brighter. And then 25. So, this way you can select the backlight. So that's like one section. And then can you go back to the computer? And then this here. So again, this was back in 2020. So I stuck a at SAMD21E18 on there, which, is the chip I use for Trinkies and for the, Trinket and Cutie Pie. At the time, it was a good idea because you had no problem getting these chips, but then, couldn't get them for a while. But I'm using this just as like a basic controller driver because, again, you have to send I2C signals to here. And also, if you want to connect to the capacitive touch, again, it has that 6-pin connector. I could practice communicating with that as well. So there's like a lot of, and also there's an I2C port that comes to the DSI. So there's actually like a lot of I2C, and there's PWM for the backlight. A lot of details to get working. Once I get it going, though, actually I'm probably going to change this breakout to remove the microcontroller and just have breakout pins, and then you can connect your own controller to it, because I don't want to depend on having the SAMD21. And honestly, like, I think once I get it going, we're not going to need as many pin. Like, there's like 3 I2C ports, and I think I can merge them all together: the DSI, the capacitive touch, and the ICN6211. But we'll see. And you also had, connected to the analog touch panel if necessary. So, the only thing I've done so far is I made a CircuitPython build for this, which is smart because I actually swapped clock and data lines, which is a rarity. Usually I do UART, RX, and TX mix-ups. This time I swapped SCL and SDA, so the pins are actually not valid. But what's nice is that in CircuitPython, I can use bitbang IO, so I bitbang the I2C, and it's duct type, so it appears as a normal I2C peripheral. So I did get, I2C data. At least it's like, it's kind of weird, right? It's like responding to every address. And like, I did see like someone tweet like, yeah, this is a really weird chip and has a weird I2C peripheral. So it would be surprising if it like was weird and it had either like freaky clock stretching or got confused if you queried other addresses, because it seems to reply to like everything. Kind of odd, but not everything, because this should go up to 7F. So it's like, it's not like a shorted pin. I actually think it really is responding to every address. Maybe, I don't know. Kind of freaky. Okay, so that's this chip. Again, it's just started. Hopefully I'll get it working, and then we'll document all the registers, and then we'll have this dev board that people can connect whatever, like bar display, round display, square display. As long as it uses that standard 40 pin TTL connector, you'll be able to use it to drive it from hopefully any single board Linux computer. We'll see. So coming soon. That's on my desk. I like to show stuff that's not ready, not working yet. So let's go to the Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Every single week, Ladyada user power engineer and help you, yes, you find the things you need on digikey.com. Ladyada, what are you looking for this week?
Okay, so this week, one of the projects that people really liked on the socials, on the threads and the blue skies, is our little mini USB hub. Let's go to the
It's called
overhead.
Skeet.
Sorry, on the Skeets. So let's go to the overhead and I'll show off this design. So this is a really simple USB mini hub. So it's got USB-C here. That's the host to the host. And then here are 4 ports with power, data plus, data minus, and ground. And this is just using an SL 2.1 chip, which is a very inexpensive, common USB hub chip that's like, all it does is the ports, and it's not very smart. I hate to call things dumb, but it's not a very smart chip. It's a very basic chip. It doesn't do anything like overcurrent protection. It doesn't do anything like indicating when the port's active. You can't change the VID, PID, or enumeration strings. It's very simple. And it's also a little big. Like, it only really comes in this large SOIC. And one thing that I wanted to note is that while these USB hubs are, of course, good if you're like, oh, I have a lot of things on my desk, or I want to integrate a product and I have a keyboard and mouse. I want them to, go through one port, or maybe you're doing some like security hacking and you want it to look like a keyboard, but really it's a disk drive or whatever. Having a USB hub in your embedded design could be really useful. Like, for example, if you have a microcontroller that has native USB, and you also have a debug port that's over USB to serial, now you have 2 USB ports, and it could be like, it could be all clunky looking. It might not be expensive to just have a hub chip instead. And I've definitely seen dev boards that have the native USB and then a debugger through like FT232H or whatever, or a SimSys DAP chip. They would use a little hub on the dev board, and that allows you to have both USB ports, connected without having to worry about like, which is the debug, which is the upload. There's like too many ports. So that can be handy. Note, of course, that if your native USB can be a host, this isn't going to work for you because it's only for like client downstream, right? The data can't go, you can't have 2 hosts connected. But I still think it'd be interesting, especially if you're having embedded Linux chips, and they do come quite small. You're using an embedded Linux board, and it has a USB host port or host pins, and you want to connect keyboard, mouse, touch controller, camera, whatever, and you want it to only go through one USB. You want to have only one USB connection to the upstream host controller. These chips would do a good job. So let's check out what we can find on DigiKey for USB hubs. Let's go to the computer. And let's go find USB hub. Now, of course, you're going to have the hubs themselves, like desktop hubs. That's what most people think of. And of course, you can use those too, but we want to have just the chips. So let's go to controllers, because I think that's actually what it is. So this is an interface controller, and yeah, now we're talking like hub controller, QFN. Now there's a couple companies that kind of like dominate this, as Infineon and TI and Microchip. So let's just look for active USB. Let's look for stuff that's in stock and exclude marketplace. So we're just looking for what's available like right now. And for USB interfaces, all these look good. It can do a USB 2 or 3. If you need 3, of course, select that. A lot of these are standalones, but yeah, you'll see like Infineon, Microchip, Renaissance, and TI are kind of like the big ones in this market. So the ones, you know, they're all going to work quite well. All of them are going to obey like the USB specification. But one thing I kind of liked was there is this series, the 251Xs from Microchip, and these come in a very cute, like 28 QFN. This is really tiny. And this is a 2-port hub. Again, could be good for, I've seen this on dev boards where it's like there's a 2-port hub to one USB-C or micro B, and it connects with the debug and the device USB, or the debug and the USB serial converter through one connection. So this is from SMC originally and then got purchased by Microchip. So very simple, like this 28 pin one is just like, it's just upstream. You put a crystal. Usually you do have to have a crystal on these because you have to give good timing. And then downstream phi, and that's it. And then each one does have, there's the data pins. There's the detection pins. This is what you're going to get for if you're going from like the SL 2.1 to something like this USB 2XX series. You're going to get more pins that tell you what's going on. So you can do power enabling and disabling. You can do overcurrent sensing. And you can do, bootstrap. It's like, I guess you can make it so devices can't be removed. Filters, of course, the crystal reset pin, which is kind of nice if you're using it in a embedded setup. I've noticed sometimes it's nice to be able to like reset the USB, especially when devices start acting finicky. They can take down the hub. And this one doesn't have any configuration that can be done over I2C, but there is, I think this one, the 2512. Let me find it. Yeah, this one, it actually has an interesting configuration setup. You can either connect like your standard 24LC04 EEPROM, and the EEPROM has the register values that you want in it, or you can control it from an I2C controller, and you can set up all sorts of specifications like, let me scroll down. Yeah. So you can set up the max power output, the USB enumeration, whether you want to have it be able to do battery charging, so like no data lines are connected, but you're still providing power. And it looks like you can do some like port mapping and port swapping. Let's see what port mapping is. Port mapping. The downstream ports can be reordered, disabled, any sequence for multiple platform design. Oh, it looks like you can swap port 1 and 2 and 3 and 4, which would be handy for your configuration. But particularly what I like is that you can set up the USB VID and PID, and that can be handy. So like when people plug it in, if you are using it to like combine 2 chips on one dev board, it's not going to show up as the microchip. Like people are going to say, oh, I thought this was an Adafruit design, but when I plug it in, it says like microchip hub. Instead, you can have it where you use your VID and PID, so it'll still say, Adafruit ESP32 dev kit with built-in debugger. And it'll show up in there on the USB, the pop-up that comes up on Mac or Windows. So this one, even though this has a little bit more pins, I actually really like this one. I think I did do a design for this. Let me see if I can find it. Development. Dev board. No, it was under breakout. No, not the MCP. I did do a design. Again, I couldn't get chips for a while. In 2021, I did a quick layout of this family. Let's see if EagleCAD wants to load up. So you can see it's similar to the breakout I showed earlier, except at the time I was using micro USB. I wanted to keep it nice and slim. It's got that cute QFN chip, and then I2C you can configure over like the Stemma QT, or you know, have it broken out over here. But this is a 2-port converter with USB host broken out and I2C configurability. So I like this one. This is going to be my pick. This one. And it's pretty inexpensive. It's, you know, you can get ones that I think go down to like $1.50, depending on, you know, number of ports and whether it has the I2C interface. But this one I like, and it's plenty in stock. So check out the 25 USB 2 XXX series. There's 2-port, 3-port, and 4-port versions. But I think if you're going to integrate this into your own development board, this USB port gives you debug and serial or mouse and keyboard, and only need 1 port. It's only a couple bucks. So check out this cool USB hub. Could be very handy for your next design.
Where in the world is that part I need? The great search with DigiKey.
And that's our show for this evening. Thank you so much, everybody, for joining us. We very much appreciate your time. We'll see everybody during the week. We have Ask an Engineer show until 3D Hangouts, JP's workshop, deep dive. We also have a ton of other things going on, along with some surprises.
And we're on all the socials. If people are like, are you on the
Yeah, we're on whatever's.
the Thread Sky,
Yeah, we're on the Skibbity Pap.
Skibbity Bath,
All right.
dash.
We'll talk to everyone later. Thanks so much.
Thanks, everybody. Have a great night. Have a great week.